this is velocity at instant for a simple harmonic motion. So, all right, we have theta as the angle on the horizontal displacement. Okay. Now, consider this place is opposite because it's directly opposite to the given angle. This place is adjacent. Okay. This is what? Hypotenuse. Now let me sketch it out. Before we apply SOHCAHTOA, we have Y, we have A, we have X. So guys, let's apply SOHCAHTOA. I'm giving you an assignment at the end of this class. So this is sine theta equals to opposite over hypotenuse, Abi? And we have sine theta equals to, what's our opposite, guys? It is Y, Abi? What's our hypotenuse? A. It is A, good. So we now say Y is what? A sine theta after crossing multiply, Abi? So at this point, guys, this is called equation 1. Okay? What is our theta? Theta is what? Omega t. A sine what? Omega t. Let's call this equation 1. Let's call this equation 1. This is called omega t. Okay? So from there, let's differentiate to get velocity. Differentiate with respect to t to get our velocity. Okay? So to get velocity, v equals to, that is to say v equals to dy dt. Okay, to differentiate it, the shortcut is this. Just multiply omega by a. What is a times omega? A times omega, that is a omega. Do you understand? The opposite of sine, the derivative of sine is cos. We have cos. Then put what? Omega t. This is equation what? 2. Okay, so let's take it again. From here, how can we know our sign? When you differentiate this equation 2 again, you are still going to get your what? Acceleration of the body. So acceleration is equal to the derivative again. Take omega here, omega times a omega. That is called what? A omega square. Abi, what is the derivative of cos? Minus sine. Abi, so put what? Omega t minus times a omega square, that is a equals to minus a omega square sine omega t. So guys, we will say that this a sine omega t is equals to our y equals to a sine omega t. So anywhere you see a sine omega t, you substitute y. So you substitute this as y. So it means that this is minus a, it means this is what? Minus omega square y. Minus omega square y. So take this as what? Equation 3. That's why from the definition of simple harmonic motion, it states that acceleration is what? Directly proportional to displacement from the rest position. The horizontal displacement, the vertical displacement. Do you understand? So, alright, take this as equation 3. Let me put it in the box. So, from there, let us from there, acceleration is directly proportional to y. That is from what? From SHM. So let me bring the two equations together for easy comparison. My y is equals to a sine omega t. Remember that v is equals to a omega cos what? Omega t. You can see that the two new, this is equation 1, don't forget this is equation 2. So from this, underline sine omega t, underline cos omega t, Make sine omega t the subject here. What is sine omega t? So you say from what? Equation 1. Sine omega t is what? Y over A. Y over A. Take note of it like this. From equation 2. What's our cos omega t? Cos omega t equals to V over A what? Omega. V over A omega. Take note of it like this. But guys, from trigonometry, you know we have something. You have to know these things. A popular question. No? They can ask you to do the proofing. So remember that sine square theta plus cos square theta equals to what? 1. This is the standard for trigonometry. Okay? What's our theta? Our theta is omega what? T. Sine square omega t plus what? Cos square omega t is what? 1. Look at this square. Sine square omega t means sine omega t square. It means sine omega t all squared plus cos omega t all squared equals to what? 1. What's our sine omega t? Remember it's y over what? A. So what do we do? Y over A all squared. What's our cos omega t? It's V over what? A omega all what? All squared equals to what? 1. So this square is for this, is for this. We have y squared over what? A squared plus what? V squared over what? This square is for both of them also. A squared omega what? Square equals to what? 1. The next thing after this is to find the LCM. Remember, the LCM is the product of denominator. In here we can see a square and omega square. So we have what? A square omega square. So take a square. A square cancel what? A square. You remain omega square. Omega square times y square. That is what? Omega square y square plus a omega square. A square omega square. Cancel this. It remains 1. 1 times v square. That is what? V square. So guys, let's cross what? Cross multiply. Cross multiply. To cross multiply, omega square y square plus v square equals to 1 times a square omega square. That is what? A square omega square. Abi? Here guys, make v square the subject. Make v square the subject. What is v square? So it means that already you have a square omega square here. So when this one comes here, it becomes what? Negative omega square y square. What is common to both? Omega square. So we factorize it out. So it means v square equals to what? Omega square bracket open a square minus what? Y square. Okay? What should we do to both sides? This square comes here, becomes square root. Okay? Or you say square root both sides. So we have what? Square root of omega square a square minus what? Y square. So now look at this. Omega square and a square minus y square, they are product function. So where square root is for this and it's also for this. Okay? We can decide to say square root of what? Omega square, expressing it further as square root of what? A square minus what? Y square. You can see. What is root of omega square? Square cancel what? Root. So our v is what? Omega square root of a square minus y square. So this value, this equation, take it as equation, I think that's equation 4, right? So equation 4 is velocity at instance of time. So guys, you know we are talking about from the diagram, from the sketch here at equilibrium, we say that displacement x is 0, right? So let me say displacement y is what? Is 0. If y equals to what? 0, it means v is what? Maximum. Oh yeah, let's substitute that. V equals to omega square root of what? A square minus what? 0 square. So V equals to what? Omega square root of what? A square. Because A square minus 0 square is A square. So square cancel what? Root. V is now what? Omega A. You can see this value is now known to find what? Maximum velocity. So this equation is for what? Maximum velocity of any simple harmonic motion. So from there, guys, you already know the other parameters expressed. T equals to 2 pi over what? Omega. Omega is equals to what? 2 pi f. So where omega is what? Angular frequency. Where frequency is what? The number of cycles makes by a complete what? Oscillation. Do you understand? So that's for that part. So I want to know that check at the look at the from this diagram now. From this diagram, assuming our x, assuming we use cos theta will be equals to what? Adjacent over what? Hypotenuse. Abi? Now what do we have cos theta to be? Cos theta is, what's our adjacent? Our adjacent is x. This x is our adjacent. We have x over, what's hypotenuse? We have a. You know that from there now we now have s equals to what? A cos theta. Do you understand? By the time you differentiate this x, you will get your v to be okay. Let me substitute a cos what? Omega t. So by the time you differentiate, you will get it as a omega sine omega t and minus here. Okay? Because the derivative of cosine is negative. Okay? The acceleration will then be minus a omega square. Okay? Derivative of sine is cos omega t. So where acceleration is now what? Minus omega square. You see, a cos omega t, just like we said there that a sin omega t is 1. Okay, a cos omega t is what? X minus omega square x. So guys, look at the ball. For this velocity at instant, let's say you are given the value of x. You can say that v is equals to omega square root of what? A square minus a square. You can still get this. It's the same thing. So anytime they mention x, just substitute your y as x. Do you understand? So anytime they mention x, take your acceleration as omega square x. Or if it is y, your acceleration is what? Omega square y. So God bless you.